Hello, you welcome back to my channel. It's a continuation of our discussion on logarithm. This is the second video. So if this is your first time here, so kindly subscribe to my channel and turn on the notification so that you can receive more videos. So here we're talking about the graph of logarithmic functions. So if we recall, we said that an exponential function, it's one-to-one, right? So an exponential function is one-to-one. So therefore, its inverse is what? Is the logarithmic function. But we know from, I think 2.8, that if we have a one-to-one function and we find the inverse, the graph of the inverse is just the reflection of the graph of f across the line y is equals to x. So if you look at this case, this is an increasing function. This is the graph, the blue one is the graph of what? Ax when a is greater than 1. So if I want to find the reflection across the y-axis, no, across the line y equals to x. So this is the line y equals to x. So if you reflect the blue graph across the line y equals to x, then you're going to have this one. You're going to have this. So as you can see, this point is what's just sample. This is the point 0, 1. But here it became the point 1, 0. We always switch, right? So because if you have a point AB on the graph of f, that point is going to be BF on the graph of f inverse. So this is our inverse, f inverse of x. So what does that mean? It means that this red graph is the graph of log to base a of x. But this is only true if your a is greater than 1. Now, in the same way, if a is less than 1, if a is less than 1 but bigger than 0, so this is our a here, not x, but a, we know it's going to be a decreasing graph. So this is the function. The red one is the graph of what? The red one is the graph of f of x equals to ax, right? But this is when your a is between 0 and 1. So if you draw your line, this is the blue line, is the line y equals to x. If you reflect this as well, we will get this shape. So let me just do something here so that it can be more clear. So this is what we are saying. We're going to have two cases here. So this is the graph of what? F of x. So let's start with the graph of f of x here. This is the graph of f of x equals to what? Ax. But here we're starting with, we want to find the graph of log ax when your a is greater than 1. We want to look for the graph. So what do? It means we have to reflect this graph across the line y equals to what? Equals to x. So if you're not sure of what to do, what do? You can just take points, right? You can take points and check. So let's see. This is a point. So this point is on which graph? This is a point 0 and what? This is a point 0 and 1. So let me put it this way. So this is going to be f of x equals to what? Ax. So let's just take ax now. Let's take, for example, take a to be greater than 1. So let's take 2 to power x. So this, the inverse is going to be what? Is going to be logarithm. So this is log to base 2 of x, right? Now, if you take this point here, this point is what? Is 0 and 1. It means on the graph of f inverse is going to be what? 1 and 0. So instead of 0, 1, it's going to be 1 and 0 here, right? Also, if you take some point, let's take a point here. If you take a point here, for example, this point, you can take it to be minus 2. If x is minus 2, what is this one? So x is going to be minus 2. And here it means you have 2 to power minus 2, right? So this would be 1 over 4. Because here I'm just taking a particular example. For example, you take a to be 2, yes? So that you can have the point. So it means here is going to be 1 over 4 and what? Minus 2. So it means this point here, let me put it in red. So this point, this one and this one. So this will become this. And then the 2 and what? 2 and minus 2 and 1 over 4. This is minus 2 and 1 over 4. It will become what? It will become 1 over 4 and minus 2. But you remember this is 1. So 1 over 4 is going to be somewhere here. So this is 1 over 4. And the y value is what? Minus 2. So you see the point is going to be here. Right? Now, we can now take another point on the graph, on the exponential graph. If you take another point, let's say here, where do you think this point will be when you reflect it across the green line? Definitely it's going to be somewhere here. But you can take a point, you can take value. So let's even make it further. So let's take it here. So this point, we can assume that this point is what is, we can give it a value. So this point, let's say x is 2 here. Remember here, this is x is 2. So it means you have 2. If x is 2, you're going to have 2 to power 2, which is 4. So this point is the point 4, 2. Now, if you interchange it, it will become what? To become x is equals to, no, it's the 0.24. It will become 4, 2. So it means it's going to be, x is going to be 4, and y is going to be 2. So if this is 1, 2 should be somewhere here. So this will be somewhere. No, let me improve this one. This one will keep going, right? So if we take x to be 4, y is equals to 2. So just somewhere, maybe somewhere here, but it cannot cross the line. So this is coming close, and it will cut. The same way, it will keep going down, but it will never cross this line, because that line is our horizontal asymptote. So this black line is what? Is the inverse function. It's going to be the inverse function. So this one, we just take a particular case. We took the case where a is what? A is 2, right? So now, if we do the same story here, let's take the same story. Here, we will take f of x to be, we want to find log a of x, but this is when your a is between 0 and 1. So we can take a particular example. So let's start with the graph, the exponential graph, which is going to be a decreasing function. Right? So this is a decreasing function. So this is not touching 0. So let's take this far away. Now this is, let's say for example, just take an example, take this to be f of x equals to 1 over 2 to power x, right? So if we want to see the graph of the inverse, which will be the logarithmic graph, you just need to draw the line y equals to x and keep going. So what you need to do now is to reflect the red graph across this line. And that will give us the graph of the f inverse. Is that okay? So this, we can, if you cannot see it clearly, what do? We take points and we take points. So we can do something like this. Just what we did here. But here you can take f of x. So f of x is what? Is just 1 over 2 to power x. And then its inverse, which will be f inverse of x. So let me make this as f inverse of x. F inverse of x, it's going to be just log half of x. Right. So let's see how the shape will look like. So here, the same story, just take some point here, take some point on the graph of f, and then interchange to get the point on the graph of y. So if this is 0, 1, it becomes what? It becomes 1, 0. So it means it's just going to be somewhere here, 1, 0. So let's call this 1, 0. So 0, 1 will become 1, 0, right? Okay, then we can also take another graph. So usually you can take some point to just see. For example, if you take any point here, just take any point here. This is also a point on the graph of f, right? If you take a point here, remember here is 1. So let's take this to be 2. So 2, if I take x to be 2, what will be the value of y? Just substitute 2 into the red function. You will have 1 over 4, right? But now on the graph of f inverse, it's going to be 1 over 4 and what? 0. So it means if I go to the graph of f inverse, we're going to have something different, right? So let's see what the point will be. Let me use the black here. So here, remember, this point is this one. So this 2, 4 is going to be 2, 1 over 4 is going to be 1 over 4, 0. But where is 1 over 4? 1 over 4 is somewhere here. So did I say 1 over 4, 0? Not 1 over 4, 0. 1 over 4, 2. So 1 over 4, 2. If this is 1 over 4, remember this is 1. So 2 is going to be somewhere here. So already we can see that this is just going to cut this way, right? Now, we can take more point if we like. You will see that it will go that way. But if you take another, let's take a point here, because this is also a point on f. This part is also on the graph of f. For example, you take a point here. So you see we've taken 3 points on the graph of f. This is 1 point. This is another one, which is the y-intercept. And this is 1. So it means we've taken 0, 1. We've taken 2, 1, 2, 1 over 4. Then let's take, this is a negative one. So let's take a negative number. For example, you take minus 1, x to be minus 1. If x to be minus 1, just put minus 1 on x. It's going to be what? It's going to be 2. So it means this point is also what? Is also 2. Because if you put x equals to minus 1, you will have 2. So you will see that the points minus 1 and 2 will become what? 2 and what? Minus 1. So you see that if this is 2, the value of x its value of y is going to be -1. So it's going to come down somewhere here. So this point so this is going to be somewhere 2 and -1. So it means that this is going to continue to stretch down all of this. So the black line is our inverse function. So in just a nutshell, so let's just summarize this. So this, it means that you're going to have two types of graph, right? For logarithm, we're going to have two types. The first one is this one. And this is only when you're what? When our a is greater than 0. And if a is when a is greater than 1. If a is between 0 and 1, it's just going to be something like this. So these are basically the graph of what? Logarithmic function. So this is when your a is greater than 1, and this is when a is less than between 0 and 1. All right, so here we have just some demonstration here. This is look at the basis now. So now how do we differentiate between log to base 2 and log to base 3? So you see log to base 3 is what? Is farther away from the y-axis than log to base 2. So the higher the base, the farther away it gets from the y-axis. So this is just the difference. You mean from the right. Okay. So here you see this is log to base 10, log to base 5, log to base 3, log to base 2. So log to base 15, for example, will be around this side. But now when you come to the negative axis, it will be more closer to 0, right? So let's just add that with a different, let's say green. So I can have something like this come in here. So this I can say, okay, for example, just take any number. It could be any number bigger than 10, for example, this, right? Why in this case, this is less than, between 0 and 1, you're going to have this. Now you see that the bigger the number, because log to base half is bigger than log to base 1 over 3. So the smaller the number in this case, the closer it is to the positive y-axis. So this is just to compare the bases. So let's quickly start sketching. So to sketch this, we have that what? This is minus logarithm. So what is this? This is actually reflection. So you have the original logarithm, which is log to base 2. But since it is greater than 0, you will have this one, right? Since it's greater than 1, you have this. So this is log to base 2 of x. Then you can now reflect across the what? The x-axis. If you reflect across the x-axis, what do you get? Remember here is 1, right? So reflecting across the x-axis. Now, how do you reflect across x-axis? To reflect across x-axis means you change what? You change y to -1, right? So in case you are having issues seeing this, what do? Just take a point. For example, this is point. Remember, when we say reflect something across the x-axis, it's like having symmetry with respect to x-axis. And I think in pre-calculus 1, if you want to show symmetry with respect to x-axis, what do? You change y to -1. So all you need to do, if you're not sure what to do, just pick some points, right? For example, if you have a point here, this is 0. This is 1 and what's 1 and 0. So if you reflect it across the x-axis, it will become 1 and what? -0. But -0 is still 0, right? So it means that it's still the same point. So it's still going to be this point here. This is going to be this point, right? So in other words, if you take another point, we take another point, say, let's say you take a point here. So if you take a point here and you want to reflect it across the what? The x-axis. So the x-axis will remain the same. The only thing is that y will become minus y. So this point, which is in the first quadrant, it will find itself where? It will find itself somewhere here in the fourth quadrant. So it means that this is what you will just have. It will just be somewhere here. Okay? All right. Now, if you take a point now, this one here, if you take a point here, you reflect it across the x-axis, it will go up. Yeah. So you have this point here. Let's say you take a point here. If you reflect it across the x-axis, the x value will remain the same, but the point now will go to this point. It will go up. So let me use this black one. So it will go here. If you reflect this point across this will come here. So it's just going to be something like this. So that is the black one. So it means we can just write it like this. So this is the reflection across the what? The x-axis. So this is log to base 2, but with a minus outside, right? Then this one, now this is reflection across the what? Across the y-axis. So you start with the original one, which is this one. Here it is cutting at where? It's cutting at 1. If you reflect across the axis, okay, let's finish this one. Here you are asked to state the domain, the range, and the asymptote. So for this one, the domain, nothing changed. The domain is going to be from where? This is what look at the graph. The domain is just going to be from 0 to where? To infinity. Then the range is the whole of R. The vertical asymptote is the line x is equals to 0, because if you look at it, it's coming closer, right? Why? Because as x goes to 0 from the what? From the right, you can see that your function is going to where? To infinity. This is the reason. Yeah? Now, here, for this one, if you reflect, so this is the graph of log to base what? 2 of x. Now, reflecting across the what? The y-axis. So you reflect across y. So what do you have? It means you just reflect it here. So it's going to be something like this. So it's just going to be something like this one here. So this is what? Is log to base what? 2 of minus x. But here now is going to be minus 1. All right. So here you can even add the intercepts. You can add the intercept here. What is the x-intercept in this case? The x-intercept here is what? X is equals to 1, right? Because this point is going to be 1 here. But for this for the B, what will be the x-intercept? Let's see what is the domain first. The domain will remain as what? Is going to be minus infinity now, but to 0. The range is still the whole of R. We have the vertical asymptotes is still x is equals to 0. And then, yes, let's even add the x-intercepts. Intercepts is x, the point, we can put it this way. We can put -1 and 0. We can put it as a point. And here also, instead of writing 1, we can just put it as a point. X-intercept here is 1 and 0. So now for this one, the C, the original graph, we can start with what's the same. This is log to base 5 of x. So this point is 1. All you need to do is just vertical translation 2 units upward. So what that means is you will have this translated graph. Because this point is 1, so we will have, if you take it upward 2 units, so it's going to be here. So this point is going to be 1 and 2, right? And then you're going to cut somewhere here. But you see that our horizontal asymptote does not change, but what will change is our x-intercept. So what will be the x-intercept? We need to find the x-intercept. The x-intercept is just by putting y is equals to 0. So you have 0 is equals to 2 plus log 5 of x. And this means -2 is equals to log 5 of what? Of x. So this can give us that 5 to the power -2 is equals to log, no, not log again, but it's equals to x, right? So x is just 1 over 5 square, which is 1 over 25. So it means your x-intercept is going to be 1 over 25, comma, 0. And we're done. So here, the point here is what is 1 and 0. So you move 2 units to the right. But here, you see that the domain, as we can see, our domain will still be the same. Our domain is still from 0 to infinity. The range will be from where? From -infinity to infinity. And what else? We have the range, then we have the vertical asymptotes. Or vertical asymptote is x is equals to what? X is equals to 0. And we can have our x-intercepts to be what? To be 1 over 25 to 0. So you can see that even if you do the vertical shift here, the range did not what? The range did not change. So the range is still remain R. So the only thing that changed here is that the x-intercept changed after the vertical translation 2 units up. So for these as well, for D, here we have only what? We just need to do the horizontal, we just need to do the horizontal translation. So we have this one. Horizontal translation is what? Let's start with the original first. This is log 2. So here is going to be 1. So this is our log 2 base 10 of x. Here, what do we need to do? We need to do ht 3 units to the right. So what that means is the transform graph is going to be something like this. You just need to move 3 units to the right. And how do we move 3 units to the right? This is 1. But look here, the horizontal asymptote is at x is equals to 0, right? So if we move 3 units to right, look at the x-intercept here. So the x-intercept here, if you move 3 units to the right, it will move from 3 to 4. So it means you are going to cross at 4. But when you cross at 4, the distance between where you are crossing and your horizontal asymptote is going to be 1 unit, right? So this is the horizontal asymptote, which is 1 unit. So usually the distance, like here now, if you see here, what is the distance from here to here? It's 1. And that is why we say the horizontal asymptote is x is equals to 0. So take note of that. Not horizontal, I mean the vertical asymptote. Sorry. So here, what can we see? This is the graph of log 3x minus, is it 3 log 10 x minus 3. So here we can see that what the domain in this case, the domain is from where to where? It's from the vertical asymptote minus 3, then you keep going to infinity. The range is what? The range is still from minus infinity to infinity, right? Because look at the graph. The graph is all to the right of the vertical asymptote. So your domain has to be from minus 3 open. Then we have the vertical asymptote. The vertical asymptote is just the line x is equals to 3. And you can see this is true because if x goes to, as x goes to 3 from the right, you will see that our function is going to where? Minus infinity. So it satisfies the definition of a vertical asymptote. So now you can see, but we have our x-intercepts, which is just 4 and what? And 0. All right. Okay, so we will come back to the graph. Here, let's just answer some problems. Example 11 here. This says find the domain of the following function. So here we're just interested in the domain. So if you want to find the domain of a logarithmic function, what do? We just want this g of x. So if you have log to base a of g of x, you want g of x to be greater than 0 because we cannot have the logarithm of a negative number, or we cannot have the logarithm of 0, right? Remember we said log to base a of x. The condition on this x is that x should be greater than 0, right? So this is just a general case. If you have log to base a of g of x, then you can let g of x to be what? To be greater than what? Than 0, all right? So before we do this domain here, we will come back to solve this problem. Let's just go and take and complete the questions about the graphing. So let's do example 11. Example 11 asks us to sketch. We're still sketching this graph, and we want to find the domain, the range, the x-intercepts, the y-intercepts, and the asymptotes. So here, what can we do? We can see that the graph is f of x is what? Log, right? So we can write this as what? We can rewrite this as log half, right? Log 1 over 2. Then here, we can take a minus out so that you have x minus 2, right? We can do this, not a problem. So it means that we can start with the graph of what? We can start with the graph of log half, which is going to be something like this, right? So this is log to base half of what? Of x. And at which point, you see this is at the point 1. And then we can reflect across the y-axis, right? Why am I reflecting across the y-axis? Because of this minus here. Because of this minus here. So this is the reflection across the y-axis. Across y. So if you reflect this across y, so it will just become what? It will be somewhere here. So it's just be the red one. So it will just come like this. This is the reflection across the y-axis, but let's do it here. So, but now it will be cut at where? At minus 1. So let's remove this from here. Then finally, now we have to go how many units? We should go what? We should go how many units? 2 units to the right. So this is HT, 2 units to the right. So if you go 2 units to the right, we will have something like this. Now here is going to be what? If this is minus 1, if you go 2 units to the right, if you go to 1 unit to the right, you will be at 0. Another unit to the right, you will be at 1. So it will just be something like this. Yes. So this is going to be 1. But we still have our what? There is still the vertical asymptote, right? So you can see the vertical asymptote now is going to be what? Is going to be x is equals to 2. So this is our vertical asymptote, right? Okay, because at this point here, you can see at here, the vertical asymptote is actually 0, right? Because you are going closer to 0. Yes, it's going closer to 0, but after the shifting, it's no longer going closer to 0, but it's going closer to 2. So let's answer the questions. So what is the domain? You can see that the domain will be what? The domain is now going to be from minus infinity to 2, right? But the range, our range is what? Is still r minus infinity to infinity. The vertical asymptote is what? Is the horizontal, the vertical line x is equals to 2. Then what else? As we can see we need the x-intercept. So what is x-intercept? We can easily find it. X-intercept is by putting y, substituting y equals to 2, right? So we're looking for x-intercept. Means you put y is equals to what? Y is equals to 0. So we're looking for, we already know our x-intercept. So y-intercept, we just put x is equals to 0. Because we already know what is x-intercept. So we have x-intercept already from here is 1 and 0. So let's change this to what? To y-intercept. Y-intercept, you put x is equals to 0. So you're going to have f of 0, which is going to be log half, right, of 2. Yes. So log half of 2. But what is log half of 2? You don't, to know what it is, we can use what we discussed before. You can say, okay, let log half of 2 be equals to, let it be equals to x. So let it be equals to, let's say x, right? Now, if you do this, this is what we're doing. Log half of 2 is equals to x. So if you do this, you'll have x 1 over 2 to power x is going to be equals to what? To 2. And this you can write it as 2 to power minus x, because this is half. 1 over 2 is 2 to power minus 1. So you'll have this, and this is to power 1. So we'll have minus x is equals to 1, and therefore x is what? Is minus 1. So now let me not use x, let me use m to avoid confusion here, because we already have x to be 0, right? So let's use m. So m is equals to minus 1. So simply it means that this point here is going to be what? 0 and minus 1. That is our y-intercept, right? So let's put everything here. X-intercept, we said, is 1 and what? 0. And y-intercept is 0 and minus 1. Okay, now the next one is this. Now for this one, we have absolute value. So all we need to do is to care about, first of all, what is inside the absolute value. And if you look at what is inside the absolute value, we can easily write as what? We can easily write as log. So for this question B, to graph this, we need to start with what is inside. We can rewrite the inside a function as, we can take a minus out, so that here becomes x minus 2. And so what does that mean? It means we can start with what's with log. So this is log to base 5 over 2 of x. Now, because you have the minus here, this minus, we can do what? We can do reflects across y-axis. So it will be across y-axis. And that will simply become something like this. Let's go a little bit closer. It's going to be the same width as this one. So let's make this. So what is this one? This is log to base 5 over 2 of minus x. Then now we can shift everything 2 units to the right. So we have horizontal translation 2 units right. So with that, we will have something like this. So here, remember, this is 1, this is minus 1, right? So if you take 2 units to the right, it's going to cross at 1. So this is at 1. And definitely it means the horizontal asymptotes. The horizontal asymptote here, sorry, vertical asymptote is nothing but x is equals to 2. So this is the graph of log to base 5 over 2 of minus x plus 2. Then finally, we have to include what? We have to include the absolute value outside. So now what do we do? Because here we have an absolute value outside. So because of this absolute value, we have to take all this part that is what? That is below the x-axis. So now we have to apply the absolute value. So to apply the absolute value, you just need to reflect, we just need to reflect this side that is below the x-axis. We just need to reflect it up. So we have to now reflect, this part across the x-axis, this part here, because of the absolute value. So finally, it will just be something like this. The graph will just be this one. It will still cut here, but now remember the vertical asymptote here is x is equals to 2. So this side you have to reflect it up, but still yet we cannot cut the vertical, can't cross the vertical asymptote. So this is the graph of absolute value of log 5 over 2 into x plus 2, everything with the absolute value. So we already know which point. Remember, this point happened to be 1. So this point is 1, 0. So we can say that the domain, in this case, so we can see the domain is from minus infinity to the vertical asymptote open. And the range in this case is going to be from 0 close to infinity. X-intercept is what? Is 1 and 0. We can find the y-intercept. Now, how do we find y-intercept? So let's come here and look for y-intercept. Remember the function f of x. Let's say y-intercepts. What is y-intercept? It's just f of 0. So f of 0, it means you put y at x as 0. This will have absolute value of log 5 over 2 of 2, everything in absolute value. So which is just a positive term. So we can even remove the absolute value. So it's just going to be, our y-intercept is just going to be 0 and log 5 over 2 of 2. So this is our y-intercept. Here, we don't need to find it because, okay, let's say if you write this as log 5 over 2, 2, if you want to find this value, you cannot, because if you say it without calculator, because if you assume this is equals to x, then it means 5 over 2 to power x will give us 2. So we're unable to write it at the same base. So it's better you just leave it in terms of log and just write it down. So here we need to add the vertical asymptote, which is just the line x is equals to 2. So this is the final answer, this one. It's the final graph. And here you can call this point log 5 over 2 of 2. All right, so let's take another one. For this one, you can see that here, the absolute value is not on everything, it's just only on one term. So another way we can rewrite this one is we can write it as g of x. Let me write it here. You can write it as g of x equals to what? Remember, this is linear. You can write it as log to base e of x plus 3 minus 1. So we can start with the graph of log to base e, absolute value of x, which is nothing but log e of x. If the x is greater than 0, in this case, x cannot be 0. Because if x is equal to 0, we cannot define the logarithm. And here is log e of what? Minus x, where x is what? Is less than 0. So it means we can start with this graph. Right, so let's just do the graph in here this way. So let's start with this one here. It's the graph of log. Remember, e is 2 point something, so it's greater than 1. So this is the graph of log e of x. So when x is greater than 0, so it's okay. So this one is log e of x. Then log e of minus x is just the reflection. So you have this one here. Let me use, say this one. So this is point is 1 and this point is minus 1. Now this is the graph of ln, or you said it log, it's fine. You can call it the graph of log to base of x. Then now we have to shift everything because of this plus 3 here. So it means we are shifting horizontal 3 units, 3 units left, right? Now, for 3 units left, what does that mean? It simply means that we are moving the whole graph by a unit of 3. So it simply means you have this. Now, this is 1. If you move it 3 times, 3 units to the left, yes? If you move it 3 units to the left, if you move it once, it will be at 0. If you move it twice, it will be at 1, right? And then it will be at 2. So it's just going to cut something like this. Then in that case, our horizontal asymptote will change. Not horizontal, vertical asymptote. Our vertical asymptote now is going to be the line x is equals to what? The line x is equals to minus 3, because here will be at minus 2. Remember, you move it 3 times. You move it 3 units from 1 to minus 2. Okay. Then this way, you have to move the what? The red one also. Remember the red one here, that's minus 1. If you move minus 1 back once, it will be at minus 2. You move it back 2, it will be at minus 3. You move it again, it will be at minus 4. So this will be something like this. So this is at minus 4. Then what next we can do is this one. We finish with, so this graph here is the graph of log to base e of x plus 3. Then now we need to move everything 1 unit down. So here we are doing vertical translation, 1 unit up, down. So with 1 unit down, what does that mean? It just means you shift the point, right? So don't forget, we have, this is our origin here. So this point now, look, as you can see, this point is -2 and 0. So the vertical asymptote will still remain the same. The vertical asymptote will not change, which is still x is equals to -3. But if you move this point is what? It's -2, 0. 1 unit down will become somewhere here, and here will be -1, because this point is going to be -2 and -1. So it means it's going to cut this way, right? It's going to cut this way. And this point will also come down here. So this point will be this one. Remember the point, we're talking of this point. So this point will be here. And this point is -4 and what's -1. Okay, so let's see how this will cut. Will cross. So let's do this first. So definitely this is going to cross somehow like this. But you can see it still goes close to the vertical asymptote. And this one will also cut across somewhere here, right? So here now, to be sure where we're going to cross, we don't know the x-intercept. So are we going to go this way? It's going to be crossing the positive x-axis, or it's going to cross the negative x-axis. So that, for us to be sure, you can use the what? We can use the find the x-intercept. So let's come here now, and let's say the x-intercept. So x-intercept means y is equals to 0. Put y is equals to 0, you have, or g is equals to 0, you will have log to base e of x plus 3 minus 1. Remember, ln is the same thing as log to base e. So you take 1 to the other side. Here becomes 1 is log to base e of absolute value of x plus 3. And then now this will become e to power 1 is equals to absolute value of x plus 3. So here we have x plus 3 equals to e, or x plus 3 is equals to minus e. So here x will be e minus 3, or x will be minus e minus 3. So we have two values of x here. So it means our x-intercept will be 2 when x is, so this would be e minus 3, 0, and also minus e minus 3, 0. But if you look at this now, you realize that both of them are negative numbers. So because look at this one, this is the most negative, because minus e is around minus 2.6 something. So minus 2.6 minus 3 will give you around, let's say, close to minus 6. So this is this point here. So it will be this point, this one. So this will be our minus e minus 3, 0. So it means that the purple one also is going to cross where the negative x-axis. So it's not going to cross the positive x-axis. And this point here, where it crossed, is going to be e minus 3, 0, right? So finally, let's get the y-intercept. We can find the y-intercept here. And what is y-intercept? Is just put x is equals to 0. So which will just be g of 0 is log to base e of absolute value of 0, right? 0 means 0 plus 3, or absolute value minus 1. And this will give us log to base e of 3, then minus 1. So this is going to be our y-intercept. So you can just write the y-intercept here. which is g of 0. So this is log to base 3 of what? Of 3. Okay. So now we need to check to find the vertical asymptote. The vertical asymptote is already, so let's put these details about the domain and all of that. So what will be the domain? The domain will still be from, it's going to be from minus infinity, but now the vertical asymptote will not be involved. So then from minus 3 to infinity. And the range seems to be the whole of R. Minus infinity to infinity. Then the vertical asymptote will change, which is x is equals to minus 3. And we already have the x-intercept and the y-intercept. So I hope this is clear. But this one, this will keep going, right? Y, this also will keep going. Yes. So I think one thing we need to explain here is, look at this one. This y-intercept here, log to base e of what? Of 3. Definitely we know this is going to be greater. This is going to be positive. So why is it positive? Because you see, this is, you can use the graph. Remember, this will be something like this, because log to base e of 3 is an increasing graph, right? And where is it cutting? Look, what is this point? If let's assume this is the log to base e of x, right? Already you can see it will be 0 at 1, right? So at x equals to 3, definitely is going to be a positive number. So, and it's going to be greater than 1 in this case because it's an increasing function. All right. So I hope this is clear. If you have any question, any comment, you can put it in the comment section. Thank you for watching.